So I'm just going to make a really quick video here, how to calculate your 95% confidence equation for your PPV data. This is something I struggled with for a long time. I, in fact, reversed engineered some of the work that was done by Brian Farmer in order to figure out how to figure out the standard deviation for this kind of log relationship, power relationship data I had. So here was a data set that I had seen. The average trend line is the purple for all these data points that are in here. The 95% confidence is the red, and they're calling it the 99.9 is the green line here. And so here were the equations, and in my part 4 video, I had shown how I reversed engineered this because they actually only gave the 95% confidence equation, and normally you start with the 50% confidence equation. So what is similar between these two equations? Well, the slope of the line, because they're parallel, and that slope is defined by this minus 1.34, and we have that in both equations. This is kind of the coefficient of the equation, which actually works out to the y-intercept when the scale distance is equal to 1. And so when we normally have this equation here, we need to calculate the 95% confidence, and we have to figure out this coefficient, and that's what I'm going to show you. And essentially, we can see that within one standard deviation on either side of a bell curve, you will encompass 68.2% of the data points, but we're looking at this 95%, and that's within two standard deviations. And so that's telling us 95% of the data will fall within these two red lines. If you want to go further afield and calculate the 99.7, which is 3 standard deviations approximately, so all the data will fall in here. That's bounded by the two green lines that we see on either side of the average trend line. So let's have a look at this data set. This is now a metric data set. We're looking at millimeters per second on the vertical axis, and the scale distance is meters divided by the square root of the kilograms charge size. And I would typically plot this log-log because that makes it easier as I'm thinking about it. Hey, where is that 95% confidence line? Much easier to see it here than it is to see on that linear plot. So I know it's going to fall somewhere in here, but I need to be able to calculate the standard deviation. And that's what I struggled with for a long time. So I take all my scale distances and put them in, and there's actually 300 data points with this data series that we're looking at, and these are all the associated peak particle velocities for the individual scale distances. And then I make 2 other columns, and one is the log value of all the scale distances, and this is the log value of all the associated peak particle velocities. And I put that into this equation, which is 10 raised to the x brackets, and this is the array of the log of the PPV values, comma, the log of the array of the scale distances, and that will give you the standard deviation. And the 95% confidence intercept, or the coefficient of that equation, is the average times the standard deviation twice. So it was a 1578.5 we saw times 1.172 times 1.172, and that is going to give me the upper boundary of that 95% confidence line, which is 2169. And so here's what that data looks like, and the way I plotted it was I just took from the range of data I had, which is scale distance of 40 to a scale distance of 200, and used the equation to calculate the points, put them on, put on the trend line, and there I have it. So you might also want to calculate the 99.7 confidence, and why would you want to use that? Well, let's say you're working in an area and you're very limited. You haven't gone out very far, so all your data is closely confined. Or you're just using the one charge size and you want to use scale distance and you want to use other charge sizes and you're a little bit worried about that 95% confidence. Well, you might want to use a 99.7% confidence until you build up a more robust data set. Because when you just have a few data points, it's not very robust. So you might want to start with that. And this is just going to kind of show that with the average trend line in the green, that one arrow is kind of showing us at a scale, if I want to stay below 10 millimeters per second, then on average, the scale distance of 40 is fine. But if I want to make sure that I'm going to be below that, then I might want to use that 95% confidence line, which is telling me, hey, keep everything above a scale distance of 50, right? And then again, if I'm not that confident, or I don't have a lot of data points, or I don't have a lot of variation in my data, then I may want to use a 99.7. And you can see I've added all these other data points in here, and in fact, they are up very close, impinging on that line, because I've gone much farther afield. And when I say that, I'm talking about 20 kilometers away from the location that I'd originally done the testing. So I would expect to see some higher and lower values perhaps as I moved around. So that's how you calculate the 95% confidence, and how you use the log values of the scale distance and the PPV to calculate the standard deviation. I hope that helps you.